Okay. Just driving that guy crazy. He still comes in once in a while and puts okay in one of the comments. That's why I shut the comment section off. I also got a guy that's getting pissed off whenever I pick on SDR radios. They're crap. They're absolute crap. So anyway, a guy mentioned about me using this. He called it a microphone amp. Now this is a cigar box, and inside is a Radio Shack circuit. Radio Shack, it was a Micronta. They used to sell this little handheld amplifier, and he called it a microphone amp. But I use the circuitry wired on perf board, and I use it for when I'm troubleshooting. It's I can put a diode on here and use it for RF trace or audio. Now, when you use this away from another circuit, it prevents oscillation. Now, I'll tell you where the oscillation comes from. If you use the same battery for your amplifier as the receiver itself, you have to do some RF bypass and some decoupling. Go look at transistor radios, and up along the top of the schematic, you'll see like a 100 ohm resistor that goes between the RF section and the audio amp, and there'll be like 100 microfarad capacitor to ground, and that creates the radio for motorboating. And what motorboating is, as the battery runs down, it gets to a point where if there's a loud noise on the radio or sound, the battery dips for a second, and then the RF drops down, and then it sort of feedbacks, and the radio will go into a loop. It'll oscillate, and when that capacitor is going bad, the radio will motorboat. When the battery's going bad, the radio will motorboat. There's two reasons why a transistor radio will motorboat: battery going down, or you need a new capacitor on the decoupling stage. So the person mentioned the regenerative set. Now, regenerative radios like the kitchen, he used earfoam and LM386, and that prevents a lot of problems. Once you want to put an amplifier in the same box with a regenerative radio, you get all kinds of signals that come in through the extra wires in the amplifier. And basically, a regenerative radio is an amplifier with feedback in a tuned circuit. So now you got a second amplifier in the same box on the same battery, and it can suddenly go into oscillation if you've done something wrong. So what Charles Kitchen did was he eliminated putting a speaker in the radio itself using headphones, and it's everything he did on that circuit was for a reason. Now, if you go look at his later circuits that have a speaker in the same box as the radio, you notice he'll use, and other people will use, a small audio transformer to separate the two circuits. And in some cases, you'll see a choke in there, and the choke usually is on the RF side, the radio side. And what that prevents is that prevents the RF from the radio. It's called a choke. It chokes out any RF that might get up onto the power supply line and get over into the audio amp section. And I also want to tell you, if you ever use these things, this is a 455 ceramic filter. These, if they're mounted on a very hard surface in the radio, and the same as the speaker, this can cause the radio to go in oscillation. This is a 455 ceramic filter, and it's not a crystal filter, it's ceramic. It's man-made material, and if you vibrate this, it puts voltage out. So besides passing 455, it also will generate voltage. So if this is mounted on a hard circuit board or a piece of perf board to the chassis, and your speaker's on that same chassis, the vibration can get in this, and at higher volume levels will cause, on certain frequencies, the radio to go whoop, whoop, like that, into like a resonance. There's many reasons for radios going into oscillation. And that's why when people shoot from their hip and produce a a regenerative radio with one tube and things like that, I get a little queasy because you can build 10 regenerative radios and half of them won't work. Maybe the wires need to be reversed on the coil. Just the way the person laid the wires out, the type of headphones they're using, the impedance of the headphones. Need high impedance on headphones if you're not using the LM386. There's so many things that can go wrong. And I just want to open your eyes to that. And that's why once you get a simple circuit going and you just think all I need to do is put it in a box with an amplifier, that's not always the case. And you can shield the RF from the audio amp, but don't forget the battery. All right, you tend to forget that. In other words, like this here, this has its own battery, so there's less likely that the RF signal from this circuit can get into this amplifier and cause me harm. So that's how I build stuff in modules. So then when I start building up, you saw my ammo can radio. As I started building it up, I found out that I was getting FM stations, garbled, but FM stations. And what it was is, once the circuit boards were inside the ammo can, the local oscillator, which would be a Franklin oscillator, was mixing with the front end, the harmonics of the oscillator. So in other words, you have it up on AM, but the harmonics of the oscillator go way up to the frequencies. And one of those harmonics mixes in with the front end with an incoming signal and produces a that's what it sounds like. It sounds like a distorted AM station. So what I did was I put my FM radio on and I went down the dial and there was the same station but clear because it's FM. And that's when I realized, I started looking at my oscillator on the AM radio. I moved it in frequency and that station moved. So I realized it's my local oscillator's harmonic getting into the front end, mixing and creating an FM station in an AM IF strip. And of course it's distorted because it needs to be decoded differently. And I found it out. I emailed a few people and none of them could figure out. I did it step by step. And one of the things is, when I put something together, I keep things in modules, in sections, and I can localize what section is causing the problem. And then I realized, okay, that section needs to be basically shielded. Now I told you, these circuit boards back here, these fit in an Altoids can. And that's originally the whole design. And then I'm changing it. In other words, I'm still going to use probably the Altoids can. But originally I had all kinds of shielded wire, and what a mess. Each can had like 6 wires coming out of it, because I wanted everything shielded. And now I'm changing my view. In other words, if a wire is only 1 inch between another module, like here, inch or so, no problem. It's when you run wires this far, something that goes like up into an oscillator. Those need to be shielded wire. Some type of miniature. I have a whole bunch of RG59 miniature left over from the old days when I built RF stuff. But RF is not easy. Originally, these guys went in, they had careers as RF engineers. And now what you're getting is a bunch of, they're amateurs. And, they're better at programming computer PICs and microprocessors than they are with RF. And that's when you look at the SDRs, software-defined radios. Those were originally made to give you television stations on your computer. And someone figured out that you could change the software and get them go and higher in frequency. And then some people figured out you could get them to go lower in frequency. Well, basically, it's an antenna feeding a mixer, and the mixer has a local oscillator, and then they have an IF strip or an IF, and then some type of detection circuit. But you're only going to get the strongest stations. And keep reading, and you'll find out that a guy goes, I bought an SDR and it's deaf compared to my handheld police scanner. Well, it's going to be. The SDR radio is designed to go from, let's say, 100 kilohertz all the way up to gigahertz. Just let's give it that. but it doesn't get all the stations because it doesn't have the extra IF transformers. It doesn't have any chokes. You know, if you look at, I told you, if you look at the last video I did, I showed you a guy builds a shortwave radio, and look at all the coils in that thing, and they're there for a reason. And when you open an SDR radio up, it's all done with software and IC chips. There's very few coils in there. There's these little tiny chokes, and that's because it gets some of the stations. So the average person, you hand them a radio, they tune around on it, they end up just using it for FM stereo, or maybe police. You can also do satellites to come over your house, like the NOAA. They have different satellites that hams use that you can listen to them when they come over the house. But you're going to have to hook it to some type of outside or special antenna. And if you look at what these people are doing with these SDRs, they're adding an amplifier to it. They're adding an antenna system. Well, go out and buy a regular radio that has that already. But what it will do in SDRs, it'll give you a wide variety of frequencies. And you can get an idea of what's out there. But it's not going to be as good as a radio specifically made for shortwave. I won't say long wave. AM-DX. Forget AM-DX on an SDR. Just forget it. Go look at what's required on an AM radio to DX with it and really get the weak stations. And in FM, yes, it works great on the local FM. It won't get out-of-state FM stations like a Sony 2010 or a Super Radio will. See, I have the good radios. I have the real radios. And I'm constantly working my budget to get a certain radio that I always wanted. And I have two SDRs, and I know the one guy picks on it because they're the old models. Well, they changed the circuitry very little. They added some shielding, which they should have on the first models. They give you the radio, and it's only half the software is in there. Then they want you to update it and give you the software you should have had in the first place. It's a game, all right? There's a lot of really good radios already out there, and I told you I got to look at the number on the radio. I think it's a DX390. The radio I use for a lot of things. Yeah, a Radio Shack DX390. On a good day, you can get one brand new in the box on eBay. And that's my go-to radio for AM-DX, FM, and shortwave. And I use it for figuring out what frequency the oscillator is on. I use it as a diagnostic tool. And that's what I was hoping to use my SDRs for. So they're terrible. They produce so much noise themselves. Yeah, I know the Russians have a better model, but I've seen them in action, and they're still dirty birds. And so is this. I wanted to tell you, this display, now that I have it on a circuit that goes from 3 megacycles to 8 megacycles, this thing's a dirty bird. It's got birds, yeah, it has frequencies it puts out all the way up the band. And if you're, like my case, my IF section is a little more amplified. It picks this thing up all the way up the band. So I'm going to need some shielding, but this is not as innocent as you might think. This display from eBay. And I told you, I actually build this stuff, and I do the experiments. And when SDRs come out, I bought one. And the first 20 minutes, I'm like, I have the antenna off on the radio. And I want to tell you something. A really good radio gets nothing when the antenna's off it. And so many people have turned shortwave radios on that were really good, and they got nothing. And they thought there was something wrong with the radio because they didn't add the antenna. And a really good shortwave radio is so well shielded, including the output to the antenna, the radio won't get anything. Now, if you're in a town with a really strong AM broadcast band station, you will pick it up on that shortwave radio because some of it comes into the line cord. And that's another thing. That's called, you got to put a capacitor to prevent that. Oscillator, something oscillator. It's not coming to me right now. But in other words, the oscillator, hum modulation. You build a transmitter and you have a really good power supply on it. but your carrier has a hum in it, and you think it's your power supply. It's not. Your transmitter or local oscillator of your radio is going through the wall. It's getting on the AC line. It's modulating it, and it's coming back into the radio as RF that's modulated. So in a lot of cases, you can just use a 0.01 across the line cord to the chassis of the radio. Put it on both sides of the line cord if the line cord isn't polarized. And that's one of the things somebody on the internet actually helped me out. I said, I got this hum on my amplifier. I said, even using a battery, I got it. Guy says, it's hum modulation. And all I had to do is go look up hum modulation. And then I realized that the transmitter was going through the air, through the wall, getting the frequency was getting on the AC line. It was coming back around. And it was pretty interesting stuff. Actually, it produced less hum when it was on the battery versus on the AC. And you would suspect the power supply. It wasn't. It's just that modulated RF was coming in through the line cord and getting back in the circuit. It's really cool stuff, RF. And a lot of people they approach RF circuits like they're digital, and they're not. They can make you crazy. And that's why they were the RF engineers. And that's why some people build all their circuits over a ground plane. They use, was it Manhattan style circuit boards? You use a piece of PC board, and you cut traces using a razor blade. And you put all your circuitry over a ground plane. And that helps out a lot. But I use perf board, and then I use a shield over the circuit itself. There's so many ways you can do this, but I tell you, you have to put the time in. And you're building something that if you contact someone, they don't really care. I contacted a couple guys about getting the FM stations, and none of them figured it out. I figured it out. I sat there and I kept saying to myself, okay, let me find out what the station is. And I used the FM radio next to it, and I found it. It was a really strong local FM radio station. It's coming in through the antenna on the shortwave radio, and it was mixing with the oscillator's third or fourth harmonic, coming right through the radio and out the speaker as bzz, 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 bzz. In little, as you went up and down the dial, there were a few of these little bzz, 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 like that, and they were FM stations. And once I realized that, put a shield on my oscillator to mixer board, and it stopped it. The oscillator signal was actually going across inside the radio and mixing in with the mixer. It's cool. It's cool. Once you figure it out and stop it, it's cool. But if you can't figure that out, it drives you nuts. I think that's it. All right, that's it.